Now there is another model which we call as APT, Arbitrage Pricing. This is called as arbitrary. This also does not assume that there is a need of any mean and variances like the mean variance theory, where you have to estimate, let me repeat again, n into upon 2 parameters, where you have to estimate this much of the parameter. So this is based on the simple notion that investors, this is based on simple notion that investors prefer greater returns to over a smaller returns. This is based on this simple notion that the investors prefer greater returns over smaller returns, a smaller one. Clear? So let us assume that this model assume the single factor. This is single factor model, means the rate of return, all right, this is a function of a single factor f. So here we write down Ri is equal to Ai plus Bi into f. Here there is, what do you find in the earlier single factor model and this model? The difference is that there is no error term. We have not mentioned any error term over here. There is no error term in arbitrage pricing theory. Clear? So whatsoever uncertainty error term, whatsoever uncertainty is there in the market, uncertainty is there in market, that is being incorporated in f itself. That is being incorporated in f itself. Yeah. So whatsoever is there, that is being incorporated into f itself. Let me rewrite down for one asset AI plus BI into f. For another asset RJ is equal to AJ plus BJ into f. Now these two portfolio in the portfolio, two assets are there, and these assets are being purchased in certain weights. So the weights assigned are WI is equal to W, and with the same logic WJ will be 1 minus W, such that sigma W is equal to 0. Yeah. Now we replace this by this will be WAI plus WBIF 1 minus WAJ 1 minus W into F. So these two assets are there. So what about the mean rate of return on these two assets? Let that be denoted by R. So this R will be equal to WAI plus WBIF plus 1 minus WA. Aj plus 1 minus WBJ into F. So this can be rewritten as WAI plus 1 minus WAJ plus WBI plus 1 minus WBJ into F. We select W in such a way that coefficient of F is 0. This means WBI plus 1 minus WBJ, this is equal to 0. So from here, if we try to calculate the value of W, so this will be WBI to BJ minus WBJ. So from here, BI plus BJ into W, which is equal to BJ, or W is equal to BJ upon BI plus BJ. Clear? So if this is equal to 0, in this special case, now we can write down R is equal to, this will be WAI plus 1 minus W into AJ. So we substitute this value, we put this the value of W into this equation, because this term will be equal to 0. So W is equal to R is equal to BJ into AI, or AI into BJ upon BJ minus BI 1 minus W plus 1 minus BJ upon BI plus BJ into AJ. So this is equal to AI BJ BI plus BJ plus, this is equal to BI plus BJ on BI AJ. So WBI. So here, if you take this on this side, this will not be like this. This will be like this, and we will have BI minus BJ upon W. So what is this? This is equal to W is equal to, with this minus sign, and again minus minus, this will be plus. So this will be AIBJ upon BI minus BJ. So this can be written like this: BI minus BJ into BIAJ minus AIBJ minus AIBJ, or this you can write down R is equal to, multiply both numerator and denominator. This can also be written as AIBJ minus BIAJ divided by BJ minus BI. This can be written like this. So what is this R? This R is equal to this much. Clear? Now suppose this is equal to this is equal to lambda 0. So this equation can again be written as AIBJ minus BIAJ, which is equal to lambda 0 BJ minus BI. So this is equal to lambda 0 BJ minus lambda 0 BI. Now we take this to let's go to another page. Another page, we have this lambda 0 into BJ minus lambda 0 into BI, which is equal to AIBJ minus AJ BI. Now from here we take this BJ on one side, lambda 0 BJ minus AIBJ, which is equal to lambda 0 BI minus AJ BI. This is equal to lambda 0 minus AI into BJ, which is equal to lambda 0 minus AJ into BI. So again we can write down AI minus lambda 0 upon BI. This is equal to AJ minus lambda 0 upon BJ. Okay? This is the general relation that must hold true for all. It's the general relation or the general result that must hold true, which is true for all I and which is true for all I and j. Clear? Now let us suppose this AI minus lambda 0 upon BI, this is equal to C. This is equal to C. So from here we can say AI minus lambda 0, this is equal to C into BI. So this is equal to C into BI. Now what do we find from here? This AI is equal to lambda 0 plus C into BI. Now, if you look into the original equation, what it was? AI plus BIF. Now, what do you find? We infer from here, or RJAJ plus BJF. Now, this equation says that AI and BI or AJ or BJ are not independent. This means AIs and BIs are not AIs and BIs are not independent. From here we can write down this Ri original equation. I had written AI plus BIF. So Ri bar is equal to AI plus BI into F bar. What is this Ri bar? What is this AI? AI is equal to lambda plus CB 0 plus CBI plus BI into F bar. So let this be denoted by lambda 1. So Ri bar is equal to lambda 1 plus Bi into F bar. So lambda naught plus, sorry, this is equal to lambda naught plus, we take Bi as common, C plus F bar. So what is this? Ri bar is equal to lambda naught plus lambda 1 into Bi, where lambda 1 is equal to C plus F bar. So this is, so once lambda naught and lambda 1 are known, once these are known, the expected rate of return, this is expected, the mean value, which is the expected rate of return, the expected rate of return is determined by this. If this is known, this is determined by the factor loading. Expected rate of return is determined by factor loading. And what is that factor loading? The BI factor. Clear? And what is this? Lambda 0 identical. This is identical to this. We talked about this. Identical to CAPM model, capital asset pricing model, where lambda 0 is equal to RF and lambda 1 is equal to RM bar minus RF. So if it is this equation Ri bar can be written as RF plus RM bar minus RF into Bi, or what you can say Ri bar minus RF, this is Bi into RM bar minus RF. And what is this Bi? Bi is nothing but under B, the beta factor in CAPM model. What is this beta factor? The beta factor B is equal to sigma IM upon sigma M whole square. Clear? So this Bi is nothing, this beta. So Bi is nothing but this is equal to beta of CA. So this is all about your arbitrage pricing theory. So in total, let me close and let me finish off. We have talked about this Markowitz theorem. Under this Markowitz theorem, we talked the decisions were being taken on the basis of this mean variance, minimization of variance. Then we talked about this Markowitz theorem. Then the second one we talked about CAPM. Then the third one is that we talked about single factor model. Then the fourth one we talked about under multi-factor model, the two-factor model, and whatsoever is true for two-factor will be true for three-factor and many factors. Then we talked about arbitrage pricing model, APM. Clear? And all this, the single factor, two-factor model, we have tried to show the relation, how this can also be expressed in terms of this capital asset pricing model, and APM, how this can be related with CAPM. So this is all about today's lecture. Thank you very much.